This morning, what we're going to be doing is exploring mathematics. Playing around, if you like. I'm not going to ask you a specific question. It's not like, can you solve this triangle, or what's x in this equation? It's not about that at all. It's about you using your sense of mathematics to investigate a problem that you have probably come up with yourself. So I'm going to quickly show you what the software looks like, do a quick demo, and then you're going to have a play with it for a little bit. And then we're going to see if between us we can come up with some aims, some problems. So this is the thing here. It's called spiralaterals. As you can see, there's a little triangle in the middle of the board, and there are 4 spaces that I can type numbers into. I've started off already. I've put a 1 there and a 3 there. If I click go, it goes, and then it stops. What it does and why it does it must be something to do with the numbers that I've typed in. Can you now go into the software, and I'm going to give you 5 minutes to have a play around and see if you can come up with some ideas about what's happening with this software, how is it working, why does it do what it does, and can you do anything fancy with it?
Take guess, right? 4. Just put it all as 4. Just have a guess. See what happens. 4 to 4
to 4 to 4.
which is a cube.
Because each box
So the
is
width, the
each
breadth.
side
Yeah, the width,
with the breadth,
breadth.
the volume.
So, what does this software do? Lucy?
When you put the numbers in the bottom, it like goes along that number and then up it and then along and then down again and it keeps going.
Right, and it keeps going. Doesn't always keep going, does it? Did anybody find anything fascinating?
If you put all the same numbers in, it just makes the square then stop.
Okay. I said a few minutes ago that we were going to look at problems and ideas. Something that we could investigate on this is, how do you make a square? Did anybody else see anything nice or pretty or interesting that was worthy of mentioning something? Lucy?
Just like if you put odd or even numbers like together or apart, or does that make a difference to what shape it does?
Okay, good idea.
Can you make a windmill without a square in the middle?
Can you make a windmill without a square in the middle? Okay. Well, that sounds like it too to me. Can you make a windmill and can you do it with... Yeah, okay.
You can make something what looks like a chessboard.
A chessboard, right. So how can you make a chessboard? That might be something that you want to try. Can you reproduce a chessboard like Lewis had on his screen? Okay. Right. I'd like you to write down on your squared paper what problem it is that you're going to try and address. So we could try putting in different numbers and see what happens. Yeah? How are you going to know not to use the same numbers again?
Write it down on your paper.
Okay, so yeah. Have any of you ever done screenshots? Yeah. Okay, so if you get something good, you want to make a screenshot, stick it into a word processor, we'll save it and we'll maybe get them printed off later. So it's the what, it's the how, and it's the why that I'm interested in. So you're going to have to make some record of what you've done.
The same as the other shape.
It's a bit like enlargement, sort of.
It does make a spiral every time.
What I'm interested in is the maths. Can you draw a windmill? Yes, I can draw 4 rectangles. End of story, you know? The question is, can you do it in one go? Can you find a pattern of numbers that will do that? Have a go then.
Then it's 1, then 5. It should work, because like that one more, so it should go 1 more down. No, that's wrong.
You were looking at the numbers, weren't you? To see if there was any connection.
Like that was 1, 3, 4,
Right.
and that one's 1, 4, 3.
Okay, so they're slightly different, aren't they? Okay. So, what you're saying is, the investigation that you decided to look at, to to avoid getting a square in the middle, you've got an answer to that. Right. Okay. And you've ended up with two things that look quite similar that might lead you to other questions as well.
We thought that because the difference between 3 and 8 is 5, and 5's in the list of numbers, and the difference between 8 and 5 is 3, and that's in the list of numbers as well. So we thought there might be a bit of a thing happening there. And then we tried mixing the same numbers, but putting them in different orders.
So see, we've switched the any two numbers around, so it's going to make it like a reflection of it type thing.
It doesn't end up where it started.
So it never stops. It just
So that
keeps
one never
testing.
stops. Okay.
Keeps
So
Tesla.
okay. So it's kind of like a spiral, I suppose.
Yeah.
Okay. So here's a question for you then: is there 4 numbers you could put in where it would come back to the start?
Yeah, because because it has to be an even number, so if you put all the same number, it would just come back as a
Well,
square.
yeah. Okay. So if it was all the same number, you get a square.
But if you also put 2 of the same number and left out third, fourth, the third and fourth numbers, it would also do the same thing because
Make a
the
right
first and second just copies the third
Yeah.
into the third and fourth.
And the pattern that it makes should reflect that. You just use the same three numbers, put them in a different order, and each time it makes one, it should reflect one that you've already done.
All right.
Yeah.
So what is it you're investigating here then?
How to make a grid in one run. We're just like trying loads of different numbers, and we found out that you've got to start off with 1, 2, 1. You've got to have 3 numbers, and then that works. And then if you just like double all the numbers, it keeps making a bigger grid,
Right.
and know the numbers well.
So 8, 12, 8 is the one you put in now.
Yeah.
The question is, why does that work?
I
That
don't
would
know.
be what I would ask. What is it about that combination of numbers that means it not only does it make squares, but it comes back to the beginning as well?
No, wait! It's done! It's done!
So, which numbers make the grid that you were talking about, Lewis?
We had them a few seconds ago, but we've just lost them, so we're going to have to try and find them again. I wrote down the wrong ones, so she changed it.
Oh dear. So you're blaming her?
Yeah.
Right. So Callum said try 3, 2, 2.
Yeah, that's it. 3, 3, 2. I mean 3, 2, 2.
3, 2, 2. Excellent. So it makes a 3x3 grid and comes back. So you know what I'm going to ask you now, don't you? Why does that happen? It's interesting, isn't it? Okay, well, I'll come back in 5 minutes and you can tell me.
Okay.
Okay? Okay, can you show what you're doing? Look this way then, please. I'd like to invite somebody up to show us what they've discovered and share with us how they discovered it, please. Right, Stephen's group is going to share with us their problem. So, Stephen, what was the problem that you were looking at?
Do all random numbers just spiral off?
Right, okay, that's a good one. Yeah. And do all random numbers just spiral off?
Depends if you use all 4. Because if you use 3, it creates a windmill. If you use 2, it just copies it into a square. If you use 1, it just makes a square. But only if you use 4 with random numbers, it just spirals off.
Right. So if we put in any 4 random numbers, it will always spiral off.
Yeah.
How do you know?
Because we tested it on the computer. And
Okay. How many times did you test this random number theory of yours?
about 5 times or something.
Only about 5. Right. Well, there's a challenge, folks. How do we know that the lad's idea is correct? Is there something we could do that's a bit more mathematical? I wonder if we could investigate something like that using algebra, using letters for each of the numbers that we put in, and thinking about it that way, so without even having to use the computer. What about the windmill? I did like Matthew and James's reflections stuff. I did like that. Click go and see what happens. Okay, so for windmill fans amongst you, that won't be a great surprise that 254 makes a windmill.
If you keep the same 3 numbers but change it around to something like 4, 5, 2, then the pattern that draws should reflect the one there.
So 452, it looks the same to me.
It is, but it reflects the one on the left because
Okay.
it's not in exactly the same position.
Again, the question is, will that always happen? How do we know? And can we explain why it happens? Now, I think I asked you earlier why that happens. Why is it that those combinations of numbers give you that and other people's combinations of 3 numbers give them that windmill thing?
Like if it's 3 2 2, it'll go 3 2 2, but then it'll start the pattern again at a different angle. So that's how it makes the chessboard, because it starts at different angles every time.
We realised that if you do 4 4s, you make a square, 4 by 4 square. So if you change one of the numbers to 8, you can make a row of squares because it like goes past the 4 and goes along 4 again. So if you put the 8 in a different place, it makes the row go in a different direction.
You can change the numbers to make it into like a bigger or a longer row, but you've got to make sure that the number that's like the odd one out, has to be double of the other 3.
How did you know that to start the arrow over there then?
It's going to go left
And how do you know it's going to go left?
because when you put the doubled number in the 3rd box along, it goes left.
Right, excellent. So we came in today and you didn't know what I was going to show you. And I put this thing on the screen and said, what does this program do and how could we investigate it? And around the room we had 14 groups and we had 14 different voices of discovery as well. What did you do? What did we do to start with the numbers?
Tested them out.
Sorry?
Tested them out.
Tested them out, just played around for a bit. And then things started to go into patterns, didn't they? Once you discovered, hang on a minute, there might be something happening here. What did you do, Sophie?
Investigated the patterns and looked at the numbers.
Then some of us tried to explain why things worked. That proved a bit more difficult because it is actually quite a complicated thing. You can go on about it for ages. And then we've come up with some nice little patterns on the screen in some cases. Okay? Right. Tomorrow, we'll be back in here and we're going to investigate the meaning of life. So just bring some DNA with you, please.